Ladies, gentlemen, fans and friends of machine learning, artificial intelligence, and data science, welcome to the 15th MLMU Online Meetup. Today, three great speakers will share their knowledge and experience with hopefully successful implementation of MLOps within a different organization. I have attended many meetups, and during this, I think I found one common characteristics of all of us. We all love building models. We all love playing with the data. Our computers are full of different script files, different notebooks, different images, and most importantly, we love to speak about our work. We love to speak about feature tuning, about fine tuning the models, and how to get better results. But when it comes to model deployment, the discussion often stop being so passionate. And also, especially people from medium and large organization start to get frustrated. And this is also shown by independent research. Model deployment or getting the model from lab environment into the production is one of the biggest obstacles for many organizations. Fortunately, in recent years, there have been a great development in this area as well. Many new tools has appeared, and I'm super excited that today three speakers from three leading companies in this area have accepted our proposal to share their knowledge. Namely, Wioletta from SAS, Michal from Microsoft, and Dorian from Google. But before I let them speak and let them share their knowledge with you, just two organizational announcements. First of all, let me thank our partners, namely companies SAS, DataClaire AI, Rosum, Seznam.cz, Konica Minolta, Hiron Hego, and Biano. These companies help us to finance the meetups, organize them, and propagate them, so we can do this meetup for you, and create a network of machine learning enthusiasts. Second, we love the questions, and questions are more than welcome. So we will use Slido, and you can ask the questions through during the talks. If you just go to the Slido, slide.do/MLMU, just write there a question. And after each talk, there will be short Q&A session. If you are not the lucky one with the most popular questions, or if there's not enough time, or if you want to ask the question in person to the speaker, don't worry. There will be a networking session. We will share the link. And please join us on our networking session. You can speak with all the speakers and also with other members of the MLMU community. So I think that's all from the organizational standpoint of view, and we are ready to start speaking about MLOps. So I'm asking my producers to send Wioletta on stage. Wioletta is my colleague from Warsaw. She's a senior data scientist in SAS, and she's got a large experiences with developing both open source and SAS models. These days, Viola is advocating and advising SAS customers with MLOps, and today she will speak about important concepts of DataOps. Viola, the floor is yours.
Thank you so much. It's so great to be here with you today. And I'm so happy that I'm able to give a presentation on ModelOps and DataOps to you today. Actually, since I have an opening presentation, I would like to provide you with general concepts of ModelOps and DataOps. Actually, I would like to start from ModelOps, even if it's a later part of analytical life cycle, because there's already a huge hype around ModelOps, and actually just recently, DataOps started to be distinguished from ModelOps itself, because actually it should be, because it constitutes some important area which should be actually perceived as separated, because it's associated with a lot of challenges, and it has actually its own specificity. So actually, I think that it's crucial to start with the reason behind we observe such hype around ModelOps. Maybe I'd like to start from a quick overview of current landscape and trends from the point of view of analytical lifecycle. So with a growing number of open source tools and packages available in the community, on the market, and thanks to their versatility and flexibility, their popularity and consequently adoption in a community and in many organizations worldwide have been becoming even wider. However, some packages like scikit-learn, for example, Pandas, NumPy, are backed by stable financing, and they have huge community of contributors, and this is the probably major reason why it earned so much trust in recent years, and it's widely adopted in the biggest organization on a huge scale. Another thing that another important aspect is that some of the emerging tools are sometimes well integrated, sometimes they are very poorly integrated with each other. Part of their functionalities overlap because they are being developed by different companies, by different departments and teams, which in some cases have different needs and expectations because their specific of their businesses is different, and their need for deployment of specific models and the business purpose of applying this model is somehow different. And that's why this workflow and model development and deployment pipelines are different. They vary between different types of organizations and industries. This is the reason why actually it's very challenging to build an effective heterogeneous analytical ecosystem, where we often need to combine some legacy software, some commercial software, and open source tools, which enable company to cover some specific technical challenges, which are crucial to reflect the complex business logic which they have in their organizations. And as we cooperate with different organizations, we observe very chaotic environments, analytical environments in those companies. One of the major challenges they face, it's lack of consistent workflow for model development and deployment. People with different skill sets actually are not able to effectively collaborate. There's no coherent governance for a team leader over the whole model development process. And as a result, there is the productioning and the operationalizing of the process of operationalization of these models is extremely slow. Business recipients become frustrated, and there is observable decrease in trust into application of AI, machine learning models, and analytics in general. So actually, it really slows. In effect, it slows down the adoption of the recent advancements in analytics into organization. So actually, that's why it's so important, and actually the way to respond to be able to respond to these challenges is to understand how the analytical life cycle should look like looks like based on our experience. Because as me as a data scientist, I'm actually responsible for developing models, but I need to collaborate with business, and actually the need for particular models, for particular products or systems based on advanced analytics, AI, and machine learning are purely result. They come actually from business, and this is the most important thing to bear in mind. So we need to listen to their needs because at the end we are supposed to embed these models which we developed into business process logic, to be able to enable them to enable business people to make decision based on this on the output from this model. So as you can see, this analytical life cycle of course starts from preparing data for exploration, modeling, then after successful model validation, final selection by team leader or by a team of data scientists responsible for a given business and analytical challenge. They decide to register a model in the repository, then deploy it, and as it's on production, deployed onto production environment, and then serves to some particular business purpose, it should be continuously monitored. So its performance, its impact on ROI, on business decision, how actually it's successful, and whether it actually meets the business needs. So, for example, whether it actually allows to earn as much profit as it was assumed, or, for example, enables to save money on fraud, because it prevents fraud cases successfully. And during this continuous monitoring, based on some clear indicators, what are the specific measures, what are the thresholds which are acceptable for model performance metrics, if some model metric goes below some particular threshold, then there should be a notification. There should be a notification generated, and there is a need notification with an info to retrain such model. Of course, it depends on the organization, and there is specific whether it's heavy regulated, but in most use cases, even if we can fully automate the retrain process, and this retrain can be perceived in different ways, as only a recalibration of a given specific algorithm, or maybe as a full model development process based on new fresh data. It rather should be maybe half automatic, because it's still important, and there are a lot of challenges related to the model interpretation and its robustness. So it's strongly advisable to not fully automate this process, but yeah, it still should be guided somehow. But at least one of the member of a data science team, because it impacts everyday business decisions. And on the right-hand side, you can see some additional part which actually reflects this complex business logic, which I already told you about. So based on outputs generated by factory of machine learning models, because this is the direction we are going towards. Based on this, we have in every organization, different processes in different departments can be very complex. So it's important to it's sometimes necessary to implement some rules which will guide, for example, which type of model will be applied to specific groups of customers, to specific clusters, or depending on the given situation, where some, for example, some time frame when, for example, we want to give some specific recommendation with promotion, with discounts, and so on and so on. So it's important to bear in mind that rules are also important in guiding this whole decisioning process. And then based on the outputs generated by those models within all those streams, the decisions are being made, and then specific actions are recommended. And based on that actions, we observe results. We should gather these results, and based on that, we can go back and get this feedback. Within this feedback loop, we can get this information into our system, and use this feedback to retrain our model, to improve it continuously. And what I would like to tell you more, that within this this agile analytics life cycle, which I'm talking about right now, actually has a plethora of benefits. Such as transparent ecosystems ensures collaboration for all team members. It gives them access to variables they produce by each of the member, to training and temporary data sets, which are versioned continuously during development of data and model pipelines. And this is a huge time saving and storage saving for them, because they share parts of their work to speed up this model development process. Another advantage of this whole ModelOps approach, DataOps and ModelOps approach is that data science teams are able to compare the models online in real time, and to get constant feedback from the collaboration with another members of the team, to see what is the most successful direction to and what type of algorithms seem to be the most successful, and where it's worth accumulating their focus and their effort in the next steps of model development. Within this agile analytical life cycle, champion challenger strategy, actually, which is based on business performance, is supported. So independently on a modeling framework, we can embed, we can register all models, no matter regardless of the technology packages they come from, and we can compare them continuously. We can monitor all of them, champion, challenger, and champion with their with its challengers, and then to, for example, replace a champion which is deteriorating, which has been deteriorating for some time, with some challenger, to guarantee high accuracy and better business performance. So apart from the model development, to make this all work out, this agile analytics life cycle, it's important to that it's all possible if we take into account the fact that apart from model development, ModelOps consists of two other components: model deployment and model governance. I would like to delve a little bit into this into details of what we mean by this model deployment. So as far as model deployment is concerned, successful model operationalization and maintenance requires, first of all, unified models, registering of unified process of model registering. So independent, as I already told you, independently of modeling framework. It should be totally agnostic, because as number of good technologies, the number of good technologies is growing. Any analytical ecosystem should be ready to adopt any kind of technology and to enable any kind of collaboration of data science members with different scopes of skills with different technologies, packages, and so on. Because the crucial reason for that is that we should not limit ourselves to only one technology. It can seem that it's much more comfortable and easy to tackle this kind of environment, but we know how to approach the challenges in such heterogeneous environment without limiting ourselves to only to one or two technologies, because due to different reasons, different types of operation algorithms for different purposes are available in different frameworks, and they are better suited for different purposes and analytical tasks and challenges. That's why it's so important not to limit ourselves only to selected ones. Another crucial characteristic of such model deployment framework, it actually should be integrated model testing. So data science team should be able to score a model in ad hoc, in automated way, right away, without any limitation. Another important thing is to ensure this continuous monitoring. Yes, so to be able to assess the accuracy of the model and its impact on business, and how the distribution of predictors can change over time, and to ensure even flexible and easier collaboration. It's important to be able to access any package, any technology using API, which a given data science member is most comfortable with. And another major component is model governance. And as far as model governance is concerned, I think that the most important thing which I would like to refer, talking about this, is this collaboration framework. So actually, there should be, we define this as such a workflow which enables, for example, a team leader, so is a person who is responsible for overseeing the process of model development for a particular business purpose, to track the progress of the model development, to be able to give feedback, to be able to notify if there are some problems, to return some remarks, which or some caveats or some challenges which or problems which appear during the development process, during, so to say, constant assessment and evaluation of the models which are developed. So it's also important for other team members to be able to know what kind of tasks their colleagues, their other data science team members are engaged right now, because it helps to better allocate resources and to share the results of work of every team member, and to speed up the whole process. And this in this model governance part, it's another thing I would like to pay your attention to is the documentation. So it's important to have transparency in what kind of variables, what kind of data sources are used by this model to generate its outputs. What are the relationship between different models, and how they, and what types of business process within the organization department they impact. And here I would like to show you quickly how the architecture of such ModelOps can look like. And on the left side, you can see actually the development stage. So this is where data scientists interact with some interactive or programming environment. And actually, during the development process, they commit, of course, they commit their changes, they progress while developing data pipelines and machine learning pipelines. And it's a fine idea to, apart from, of course, simple versioning to local Git repo and to remote repo like GitLab, is to use and apply CI/CD pipelines to additionally validate, test and validate based on different criteria which are specified by a given data science team to make sure that that a given model could be properly registered and doesn't have any detrimental effect on business process after deployment. So after that, there is a registration to SAS Model Manager. And then after that, we have publish. So the model is supposed to be published on one of engines, and then there is after that, subsequently, we have a trigger for CI/CD for a final validation to the, for example, pre-prod. It depends, of course, on the organization, to the pre-prod environment, and then after next validation, it's possible to promote it to production environment and to schedule after deployment onto production. Actually, along with this process, actually the retraining process should be scheduled accordingly to the business needs or based on some business performance or manually or in semi-automatic way. And now we are approaching to the place where ModelOps meets DataOps, DataOps meets ModelOps. Actually, the heart, actually the middle of this, where this both methodics meets, is actually the stage where there is model development. DataOps is in general, sorry for that, I would like here to tell you not only about the data concept, but actually about data concept and feature store as its core component. DataOps concept started to be distinguished because, of course, for a couple of years, we've been all aware of how challenging, how important is data integration, data cleaning, data cleansing, development of efficient ETL pipelines, and so on and so on. But it's I think that people started to understand there is much more behind that, and they decided to distinguish this concept from ModelOps because often a stage of the stage of when at which actually consumes a lot of time is feature engineering, and feature engineering can be simplified, can be done in more automatic way using deep learning to extract some more condensed information using some autoencoders and so on. But feature engineering is still an important stage of model development itself. Especially in areas and applications which requires more interpretability on a lower level of granularity. So that's why we should focus on how to organize this process, especially when you take a look at this example of architecture of DataOps process. I think that most of you are familiar with that. So when we begin with data integration, we analyze data, do some exploratory data analysis. We defined our target variable. If we have supervised problem, we sample data, we do variable pre-screening and the feature engineering itself. But it all makes sense, and it all can be speeded up if we enable data science team to collaborate, to share their work. Above all, in many situations, it was challenging to deploy model because of not being able to reflect feature engineering, feature transformation, which was done during model development in the production environment. So that's why it's so important to do the feature engineering along with continuous feature versioning, so committing features to Git repository for the purpose of collaboration during model development, but also for the purpose of production phase and production environment, because production environments should have continuous access to feature definition to be able to calculate some of variables on the fly. Whether it's more real-time online models or even new real-time models. And how the feature store actually can be organized. This is some example of how the feature hierarchy can be organized. So starting from entity can reflect the data source type. So whether it refers to client, customer, or transaction, or contracts, or any, so to say, business data source. And then it can be organized split into feature sets. Actually, this feature set is aimed at reflecting some kind of logic which corresponds with the same type of estimation calculation process. So in order to speed up the calculation of such features, they are organized into one feature set. And there are a lot of metadata associated with the feature set, which guarantees transparency and auditability for this feature store. And at the lowest level, we have single features along with their specific metadata. And approaching to the end, I would like to show you only how this process from the perspective of data scientist could like. So we can, such a data scientist during the data pipeline development phase, for example, could define features from the scratch based on new or existing data source. Then he or she sends a new variable to feature store, and it's actually corresponds to committing a feature set. So we versioning a feature set because we need to assign a feature to a feature set. Then we, because this is how this logic is organized, then another approach would could be like that. That, for example, data scientists take a feature definition from feature store and modify it somehow as requested, because he or she discovers some bugs, or for example, wants to develop some new features based on that, and so on and so on. Then after that, this change and the new version of feature set to which this new feature is assigned is committed to feature store. And based on that, we can generate a data frame which can be shared, which can be some temporary stage data frame or the final data frame, final data sets to be used by another team members. And the production phase. During the production phase, actually data scientists selects which feature sets should be deployed to production environment. Then he or she decides where and how feature sets should be actually deployed, whether it should be deployed on some online or maybe a batch engine. Then deploys it using one-click button. And then schedule it depending on whether it's modeled for batch or real-time purpose, and then can schedule the frequency and time horizon and pre-evaluate the data. And in case of real-time, model can be cached in memory or as a service or a fast database. For the purpose of scoring online. So thank you. That was my part. Thank you for your attention.
Thank you, Wioletta. Thank you very much for a very interesting talk. We are slightly over our schedule, so we have some question of Slido, but we will need to keep it. And there is a motivation for you and also for our audience to go into the networking session so that they can ask the question directly to you. I will just add that for the persons interested in ModelOps and in SaaS approach to ModelOps, there will be a webinar on the June 3rd, that means next Thursday, about ModelOps. And during this webinar, there will be a roundtable with really people from the industry who use this in practice, for example, from Škoda Auto or O2. So if you speak Czech and if you're interested, I welcome you to join. We will put link into the chat. Viola, thank you very much.
Thank you.
And without losing any second, I welcome Michal on stage. Michal comes from Microsoft. He was a data scientist for many years, and now slightly shifted his career, let's say. And now he's a solution architect responsible for data and AI in Microsoft. And today he will tell you about his experiences with MLFlow and how MLFlow can help with successful experiment tracking. Michal, the virtual stage is yours.
Thanks, Johan, and welcome everybody, and thanks for having me. So I'm gonna give you a short talk about the, I think a necessary part of the whole MLOps life cycle, and this is basically an experiment tracking, right? Because if we take a look on the traditional, let's say, systems which producing some code, like in software engineering, so which are using DevOps principles, and we take on the ML infused systems, like systems which are developing some machine learning models which are running on top of the data, the kind of a DevOps practices can be definitely reused, but we can see that the whole system as such is a much broader and much more complex, right? There are many things you need to bear in mind in terms of your data which are fooling your models, which you need to take care of the models itself, testing and versioning and registrations and all these kind of things, and also when you're deploying the model into production, you need to, let's say, take care of a few things about how the model is performing in production and so on and so forth. So the whole ecosystem towards these like DevOps principles is much, much broader. But on the other hand, if I'm thinking about the MLOps, I mainly think about three like major things, which is the reproducibility, right? Because you want to have a reproducible experiments, especially when you, let's say, train another model, so you need to have reproducible results, right? The second thing is automation, right? Coming from the DevOps idea itself, right? The whole CI/CD is about having as much automated system as possible, right? I'm not saying that you will have everything fully automated. There can be, and then in fact are even advisable to have some manual interventions and and approvals and things like that. But mainly it's about being as much as automated as possible. And the third thing for me most important is productivity, right? So to have all the tools and the systems nicely wired up to have the maximum productivity you need to have in order to bring some sort of projects and in the end the products, right? And the DevOps loop, because in the end it's all about the DevOps lifecycle, right? It looks, for the data science part, it looks like this. So basically you start with your code development inside your favorite IDE, right? So be it Jupyter Notebooks or whatever IDE for PyCharm or whatever, right? Even VS Code is pretty used in here. And then you train your model, test your model, you create some artifacts, and you register the model, and if you are happy with the model enough, then you build some deployment package, which should be a Docker image in the end, and then deploy the service, and the loop goes on, right? So you monitor it, and you have pretty nice loop, and all the things covered, and the governance around is called nowadays an MLOps, right? And how MLFlow talks with this, or how MLFlow plays a role in there. So maybe just a slight introduction into MLFlow itself, if you don't know. So it's an open source platform, actually heavily, I would say, contributed by Databricks and Facebook and Microsoft, of course, and all these kind of companies and big names are talking about this and somewhat contributing. And the platform itself is built to kind of manage the whole machine learning lifecycle, right? So it's about the tracking of the experiments of your I would say the most creative part of the whole lifecycle. So when you actually build the models and train the models and see the results and see how it goes, and this is the most interesting part, of course. And then about some projects, so basically what are the typical environments and workflows and things like that. And then definitely the outcome of the whole process is some model, right? Some artifact which represents the trained, let's say, weights or whatever, and you need to have a mean and the power to actually register it somewhere, to check track the versions and then maybe deploy the models into production lifecycle. So this is basically how MLFlow kind of covers this whole area. So it has lots of components, but basically, and it was initially built about the tracking of your experiments and things that you are actually building and see what's happening there. So the heart of it is really an tracking server, right? So basically some component which actually tracks and keeps metadata and keeps some kind of a database of the already run experiments. So basically, what is actually running, what has run in the past, who actually run the experiment, what was the result, what was the parameters, and things like that, right? So this is like the whole heart of the MLFlow. And of course, in the end, it's like the syntax, right? Because it's simply just in some package into your Python environment, like you just import an MLFlow. And from there, you can use things like, okay, right now I would like to, let's say, train the model. And when I'm training the model, I would like to log some metrics, for example, right? So maybe I would like to log an accuracy of the model, or any arbitrary metric. I can log parameters, I can log the model itself, I can log some images from charts, for example, and things like that, right? So it's really just a kind of a logging technique, basically some few lines of code which are on top of your code which you're used to it, right? So instead of writing print something on the output, you will do an MLFlow log, basically, right? That's the idea. So very simple, very lightweight, but very powerful, as you can see, as you will see in the end, right? And based on that, you can have some, can have GUI, but you can have even SDK access to it, and you can browse it, and you can browse the logged parameters and metrics and everything, and evaluate it, right? So this is that's the basics of the MLFlow tracking. And on top of that, there are some, nice, I would say add-ons and, features where you actually can start something like automated logging. So meaning you don't need to manually express this metric log or log this model, but you basically, based on known packages and known open source, frameworks like TensorFlow or like GPM and these kind of things, you can basically just start auto-logging automatically, right? So basically everything, or the most important parameters and metrics, are being logged automatically, which is kind of nice and handy if you're building such a systems. And how it can look like in the end, so you can visualize it, so you can go to individual run and you can see what was the parameters and metrics, what was the, even the metrics charts of it. So these are being automatically kind of created, like from the individual, let's say, timestamp from the process and so on and so forth. But I would like to, in the end, show you how things are going with this, and what is kind of how I am using that in the end. But I will show you in the environment of Azure, which is a public cloud, and our Azure ML service, right? The service itself is focusing on whole, let's say, life cycle of the ML kind of a environment, right? So meaning you can develop your scripts in there. So you can use your IDE, or you can use basically any IDE in there. You can create and manage compute targets. So basically, what is actually running your script behind, and you can submit and track your experiments, right? So in there, so you can submit an experiment into the remote compute, for example, or in your laptop. It doesn't really matter, and then track the individual metrics and records through MLFlow. And then you can browse and see your log metrics, and then can switch to a past runs and compare and things like that. And once you are kind of happy with it, so you can then register your model or persist your model and register in some model registry, and then create your image from it by just a few lines of code, basically, and deploy it into an environment, whether be it to your cloud environment or your on-premises environment or your edge device, for example, in case of IoT and various use cases, right? So it's a really service which helps you with all these kind of governance and management all around the model lifecycle, I would say, right? And how it pairs with MLFlow. So we are actually using, so Microsoft is open to open source. So we are actually using and benefiting from various open sources here and there. But MLFlow is one of the, let's say, I would say, currently, I would not say standard, but rather, let's say, very well adopted framework for using this. So instead of kind of a competing with it, we just would like to, let's say, embrace it, right? Really, because this is a nice piece of open source, right? So the idea here is you would normally use your MLFlow as you would do in any systems, only you just wire it up to to an Azure service basically, and then we are providing with managed MLFlow server when you can use it, and then you can log your models, metrics, and models deployment and so on and so forth through the your familiar MLFlow APIs, right? So you have everything you know from MLFlow already. And okay, so let's get some real picture of it. So I will kind of show you what is how does it look like. So I just open a simple Jupyter notebook which does a really simple machine learning train model, but it just showcases how you would use MLFlow in a real example, right? So what I'm doing right now in the beginning, I'm just wiring up into the service. So I just read some config and log into my machine learning workspace in Azure. And when I'm using MLFlow, I basically just, and maybe I just slightly increase the font just for you to better understanding what's already there. So, and I just wiring up here setting the MLFlow backend. So I'm just saying, okay, my MLFlow is not any arbitrary server or VM or whatever. It's rather an wire it to my Azure ML service, right? So this is the one line of code you need to do to change your where your data is located, basically, nothing else. And then I would do everything what I would do as an through the normal process. So I have okay, step back in Azure Machine Learning. You have some concepts even for data sets. So as Viola was saying, so the DataOps and taking care of the data sets and what was the version of data set and everything. So we have a concept of data sets in there. So you can get your data set sitting somewhere in the storage, and you can load it in here, load it in the pandas data frame, and work it as you would do normally with traditional data set, right? So you can just get some understanding what the for example the target variable is. So this is just a plain diabetes example of predicting some metric based on the various predictors. And when I would like to train locally a model, so meaning within this Jupyter notebook, right, I would basically just set to MLFlow, okay, my experiment looks, or the name of the experiment would be like this. So this is like a container for all the runs and all my experimentation, right? And then it's just plain scikit model. So I would do just split the train and test. I will use an LIGBM modeling for it, and then I would start proper training, right? And I just need to do here an MLFlow start run. So from that, when I hit the cell, I basically from then on I'm start tracking the experimentation. So with the MLFlow, then I set some parameters. I can just log them because I think it's for me as a somebody who's creating a model, it's very crucial to know about the input parameters to the model. So whether be it some hyperparameters of the model, but it can definitely be some other strings like or other metrics like I don't know what is the type of the model and things like that, right? And then I just hit or set up the regressor and then just fit the model, right? So this is what you would do normally even without MLFlow. And then when I'm in the end, I will calculate some metrics on top of that, so mean square error in my case, and I will just log the metric, and then I will just log the model itself, right? So without further ado, I just run the example. So this is a pretty small data set, so it will be really fast. So as you can see right here, this is the output from the GPM. So basically some kind of a stages, and then in the end, there's a mean square error of some arbitrary number, right? So what just happened there is I basically, this is nice, right? This is nothing, let's say, very specific or special. But what is nice is that underneath, I started to log the experiment in this particular experiment, right? So I have here, this is actually Azure Machine Learning Studio. This is like a kind of a GUI of your experimentation, which are created by the MLFlow. So you can see in any arbitrary GUI, but in my case I'm using this one, and you can see this last run in here exactly is the run which I submitted just now, right? So 706, and then drill down into an experiment and to the particular run, I can see some parameters here. I can see the metrics in here. I can see some details, right? So when it was created, started the run, what was the duration, what is the status, who is actually running the experimentation, and so on and so forth, right? And just to bear in mind with this demo, I'm currently running on in this Jupyter notebook, so it can be literally my notebook or whatever, right? And then comes the another thing and another principle. Currently, the using basically bigger data or using like data which resides somewhere on storage or online, or I simply need a bigger compute for the training, right? So it's a good idea to basically have the same script, but submit the experiment into a remote environment, I would say, right? So right now, I just say, okay, I have my cluster up and running in the cloud already. So I just wired it up. I say, okay, this is my cluster, and let's use it. By the way, it's just a small cluster, about one node of some 2 cores and 7 gigs of RAM or something like that, because the data are small for this demo. I will tell, okay, because I'm submitting a run, it needs to have some code base, right? So where is my codes located? So this is just by this setting. Then I just get the data set as I would do like normally. So this is my data set for the training. So it's like a pointer into a storage, and they are just define the environment, right? So very crucial part of the reproducibility step in your process is to have some environment defined, which you can say all the dependencies of your pip and conda packages for your Python environment, right? So what are the packages you will be using and running, so you have the reproducibility in place, so whether anybody else can take the environment and run exactly your scripts, and it will be working right in the end. So it's like defining the environment, and from there it's just in defining the configuration of the actual submitting the job, right? So this is what is my training script. So basically what you see so far, it was just a few lines of code. So this is my training script. This is my compute target. This is my conda environment. So basically the environment I just defined a literary step before, and these are my arguments, right? So what is the input data? Because we are now running on some arbitrary virtual machine. If I put it like this, it's in fact a scalable cluster of machines, but it's just something away which can be even created on demand basically. And then I put so that's why I need to do some pointers. So I see the data are located there, and then I put my parameters to my model, right? As you see previously, and then I just basically hit run the experiment, right? This is all. So basically, what's happening right now is basically submitting a job. It's creating a package from my environment. So meaning I will just pack the project folder, so all the train py scripts and all the other scripts with my for example libraries, and sending into the cluster, right? And in the cluster there is running a Docker container, which is being created based on the environment I just said, and in this Docker container is running my scripts, right? So we have some kind of a handy I would say visuals on top of Jupyter, so you need to switch to the studio back and forth. You just can literally stay in your IDE environment and just take a look what is actually doing. And currently what is it doing is doing the same as we do previously, but currently it's running somewhere in the, I would say, cloud, right? So it's running on the remote compute. It's just submitting the script, and has to do some sort of some more steps, like the fetching the image if it's not already there, or maybe check if the image is the Docker image is there, and then inject the scripts and then run it. So it takes like more time, but it's already completed. As you can see, you have some metrics in there. So everything is logged through MLFlow, so I can get access to it. I can see my MSC and so on and so forth. So when I switch back into the studio itself, into the ML Studio, I can see there is another run created by the MLFlow process. It's in here. So it was like 39 seconds long. Right from here, actually, I can see some basic comparison about the metric which has been produced. So basically, I'm currently just measuring the MSC, but I can have literally arbitrary number of metrics what I would like to. So basically, these are my basic informations about the individual runs. So I can see that the previous run, what was the metrics, and so like prediction accuracy and all these kind of things which I'm measuring, right? Sorry, different space. Never mind. So yeah, this is my step before, so I can just hit the refresh and see what is happening there. But it stays the same. So these are my experiment or runs, individual runs that I just submitted, right? So you can see there was a script. It was my MSC in the end. So you can see there are differences. So you can easily compare them. And when I drill down into the metric or into this particular run, I can see the other details. So basically, I'm with some run ID, when it was created, how long does it take, and also some parameters and tags for an individual run. You can see there is also lineage of datasets, so it's kind of wired. So if I take a look on the dataset itself, so it's registered as a diabetes multiple dataset, which is called. I can see things like the exploration, so I can see what is the dataset about, what is the version. So we are also you can track of the version of the dataset which the algorithm or the model has been trained on. So you can quickly do some preview. You can have some pre-populated profiles, so you can see that some metrics about the actual dataset, and this is a kind of a lineage for your experimentation, right? And when you take a look on the experiment or run itself, so we are also capturing other things, right? So in the output and logs, you basically have your trained model, right? So you're keeping track of your model. So this is a MLFlow way how you log a model. So basically you can have some artifact, and from there you can take it and deploy it into production. You have some snapshotting here, so you can see all the train script which has been issued and what has been actually run. So as you can see, this pretty much the same script I showed you already. There is some environment tracked and so on and so forth, right? So with this, you have currently in your hands, you have a means of how you can basically reproduce the flow once again. So you have the lineage on the data, you have your scripts captured somewhere, you have an access to it, you have access to the trained model, so you have access to your metrics and parameters which created the model in the first place, and then you can compare it between those individual runs and see what model was performing better, and so on and so forth, right? So either you can do in here some parameter sweeping and have some child runs and everything. So this is all the capabilities which I think are very crucial for every data scientist to be, productive, to boost the productivity of every data scientist. So with respect of the time, I probably end up here and leave some space for Q&As.
Thank you, Michal. Very interesting talk, very interesting demo. So we have one question as of now on Slido. Are there any downsides or missing features that you miss in MLFlow and that are available in alternative tools?
Well, it definitely depends what you mean by alternative tools, right? But currently, I think that the MLFlow is de facto the kind of a standard, right? It's open source platform having all the things and needs which I think is crucial for a development kind of a life cycle, right? I would slightly doubt about the productionalizing of the model. So not doubt, but I think there are still, the tool itself is fairly new and it's improving every day, literally, right? If you take a look on the repo, there is a submit once every, I would say, month or even week, right? So the features are coming, but for the deployment, that is currently there are some weaknesses, right?
Sure. Another question arrived. Is there a support of A/B testing scenarios? Are you aware of that?
Not really. You can have and you can create those, but you can probably do it manually, right? In MLFlow is not meant to, let's say, do an A/B testing. But if you would like to use an A/B testing for your model and some canary deployments, we might be interested in and check out probably what we have just announced on our build conference literally yesterday. It is something called manage endpoints, and you can do exactly like that. So you can do a deployment of your model into a managed endpoint, which you can do A/B testing on, and you can specify it, and you can do canary deployments and things like that very easily.
Okay, thank you very much. As I said, very interesting talk. Thank you for being brave enough to do a demo. It can be sometimes tricky to do live coding demo. So thumbs up for that. and we're going to the next speaker.
Thank you.
So I welcome Dorian on stage. Dorian comes from Google, and he's currently based in Bucharest, so it's really international meetup this time. Dorian comes from Google, where he works as a customer engineer from smart analytics. But what I learned from him is that he basically went through multiple big tech companies, also SaaS, also IBM. So he's got a lot of experience with different technologies. And I'm really looking forward to his talk about using AI platform for MLOps. Dorian, virtual stage is yours.
Thank you, Ivan. Thank you very much. Good evening, everyone. Hopefully you've still got the energy so late in the evening to follow a few, let's say, slides from my side. I promise I will keep the time as much as possible. The idea is actually to go through some interesting topics. I have three main areas to show. First of all is how to, let's say, approach the AI or ML framework adoption, and this is something that I think it's interesting for everyone involved in this, let's say, part of the world. The second one is understanding what Vertex AI has been launched by Google and why it does and how it helps in the MLOps area. And the third topic, which I think is also very important, is to focus on a customer who has done a lot of, let's say, good and bad things, and is sharing a lot of information for all of us to learn and approach it properly. So let's start with the first one. The adoption framework is pretty much focusing on this, let's say, drawing or this framework that you can see here. It's putting together four important parties in the machine learning area, which is people like you and I, and we're all working together, as well as managers and all the, let's say, people using and benefiting from the ML world. Data, which everyone is talking about, and it's pretty much the core the way that we, let's say, get the freedom to work with data, and very importantly, technology and how it all links together. In order to, let's say, put it all together, you need to link it to 2 by 2. And here we have the lead, learn, access, scale, secure, and automate area. What it means is that different companies in different ways approach it differently. So in terms of leading is how people lead with processes. If a specific team structured, where are the, let's say, the data scientists? Is there any department? Are data scientists involved in all the processes, in all the initiatives? Do they know the business outcomes, and so on? Then the link in learning is putting together people and technologies. What are the skills required in the organizations? Is there any training? Is there any talent development? So all these kind of things in order to keep up with the new technologies that are showing up. The third one is access. People have access to data. Is it, let's say, in a very democratic way or the opposite way? How is it being done? How do you make sure that the proper data is being accessed by the right people and that the machine learning is being done on the right data? So these are actually questions that allow you to understand where the maturity of the company or the organization that you're working in is. As well as scaling, data of technology. Right now, there are a lot of tools on the market, free, charge, cloud, on-premise, and so on, that might end up with a lot of headaches with everyone trying to adopt something. So the question is, how do you make the data with the technology work together and accelerate it as much as possible? Security, this is a very hot topic that I see, and everyone is trying to understand how to approach it. A lot of tools are available on the cloud, and there's always this question about security. So how do you put together processes in order to secure the data? And how do you make sure that also everything that's related to AI, ML goes in this direction? And the last topic, which is the automation, and is very much linked with the MLOps world and what we do today, is the link between technology and processes. So how are model updates being managed, and all the processes and everything that's behind it inside the organization, as well as how ML quality control is being taken in place. And all these, if you put them together and you do an analysis, you can find out a little bit more about all these, let's say, steps on the Google website. Would give you a good overview of where are the gaps, what's the maturity in AI ML world for the organization, and how this can be put together in order to get the best results for the company. Stepping forward, we're going to take a look into the Vertex AI, and this is pretty much a new name on the Google website. It was launched as an overall concept and product and mixed together and so on, I think last week on 18th, if I do not miss the date. And what it is pretty much an evolution of a unified AI platform, which was giving the data scientists all the tools necessary in order to meet the MLOps world. Right now, the end-to-end platform, as I'm able to explain it today, because you'll see there are a lot of interesting things that are going to show up. Some of them are in beta, some of them are in preview, some of them I don't even know myself too much about, and will be, let's say, launched quite soon. The idea is we're discovering four different topics that are very important. So velocity of model production, how to make it as fast as possible to production, and which are the tools that are benefiting and data scientists, and not only, because this is also very important, can be used. Algorithms specific from Google's world and Google papers, how they are, let's say, leveraged right now in the Vertex AI, as well as how to put, let's say, the Vertex workflows to scale ML as much as possible. Most important is the last one with the model management and governance, and how a lot of topics and a lot of steps have been done in this direction in order to make sure that it's a lot easier for, let's say, a lot more people involved in the process to work and understand the model management topic. Now, getting models into production faster is a very important topic, because we all know it starts from the ingestion of data, analysis, transformation, a lot of training, retraining, as well as tracking of a lot of KPIs related to the models, and then getting into the evaluation and finally deploying it into production. Now, if you look here, there are a lot of steps and a lot of time being spent on a lot of topics. Most of the times, and a lot of our customers that I'm working on and all working with, do a lot of work on the data area. So they would like everything else to make it as seamless as possible in terms of processes, because data is pretty much something that is not always under their control. Now a new, let's say, new word, or let's say a new concept that's on the slide here is the NAS, is neural architecture search, is pretty much trying to help in getting the right structure of neural networks. It has quite impressive features. There are quite a few papers that are being launched, as well as how it works, what is the architecture behind what it's doing, and is right now part of Vertex AI. So you can leverage it when you're building more complex structures in order to get better quality, or just build them as fast as possible in the testing, maybe tens, hundreds, or thousands of models in production. Third topic is the Vertex pipelines, which is part of right now of Vertex AI, or the new unified AI concept. That's helping build things a little bit easier and putting together a lot more processes in more technologies. So as you can see, it's pretty much a pipeline that will put together all the steps: extracting data, validation, preparing, training, evaluation, as well as validating and deploying it to the runtime. Then it's a very tight integration, and I think this is an important aspect to bear in mind, with BigQuery, in order to do a lot of processing there, or extract data and play with it as much as possible. DataFlow for the ones that have already started or implemented such technology in the past. as well as for the unstructured data that in Google Cloud would be residing on cloud storage. And this gives you an overview how to work with all types of data on the Vertex pipelines. And I think this is a good benefit for the ones starting right now VML world. Now, Vertex AI is pretty much going into covering some gaps which I think are very important and everyone is asking for right now on the market, which is a lot of things related to documentation. Everyone would like to have it. It's very hard to produce, and as much as things are changing overnight or very fast when you're building hundreds and thousands of models in a big organization, you need to check what's happening. So there's a lot of, let's say, automated things that are being offered by Vertex AI in the documentation or ML metadata. Another important thing is the, let's say, explainability of a model. How easy it can be understood, how you can actually track what's doing, especially if you're using images in order to build image models. And this is the area where explainable AI, part of Vertex AI right now, is doing a good job in, let's say, in covering this topic. Then there's also important things related to user trust. And my intro on the framework of adoption was not, let's say, out of the blue. It was, let's say, going specifically in this direction, because more and more business or data analysts would be jumping in the processes. So for them, it's very important for you as a data scientist to get their trust. So explainable AI together with the pipelines which are readable, or let's say more human readable, is very important, because this is where you would get trust and adoption as fast as possible from other parties in the organization included in the process. Then accountability, this is also something that everyone is again talking about. Bias optimization and a lot of industry standards that need to be met specifically for let's say legal or legal specifically responsibilities that need to be covered. Then another, let's say, thing is the data labeling. Most of it is covering in the image and video applications. And here's another, let's say, hot topic that the human in the loop approach is very much needed. If we move forward, Vertex AI is pretty much covering these three topics. The one in green is with streamlining the MLOps is the one that pretty much you will be seeing the advantage, as well as developing AI application and let's say with the one in blue, machine learning and data science as easy as possible. Now, Vertex training goes together with let's say two more areas where you can actually build models within the Google Cloud Platform. I don't know how many of you have used, but I would like to explain it in a second. BigQuery machine learning is pretty much a set of models that are running on top of BigQuery, the data warehouse solution from Google Cloud, that are actually built for the ones who have a lot of SQL, let's say, scripting as well as SQL coding knowledge. And these are the ones that would be building very fast models for prototyping, testing, any kind of these applications on top of BigQuery. Most of the time, this will not be data scientists, would mostly go on the data analysts or the ones who are just starting to understand how these can be built. Then there's AutoML. AutoML is a very nice functionality that comes from Google that allows you to build a lot of, let's say, models very fast without caring too much of models behind, how it's being put together, how they work, and so on. However, most of these will still reside on the people who have, let's say, not so advanced data science knowledge. And then there's the Vertex training, which gives you a lot of freedom in doing everything. But you also get the possibility to put together the other topics that you've seen so far. Now, if you go forward, the AutoML, let's say, workflow in Vertex AI tries to put together a lot of the traditional, very fast, let's say, mostly used models. and try to build them as fast as possible on your data, on the data that's available, covering feature engineering, model selection, as well as hyperparameter tuning. And then what you would need to do as, let's say, a data scientist or data analyst mostly, because this is the, let's say, the type of audience that it's trying to cover, is cover the following steps in evaluating, and if it makes sense to go forward with this one, build one from scratch, or if it's a need that needs to be, let's say, satisfied in a few days or a very short period of time. This would be a, let's say, the go-to model whenever you have something that you do not have enough time or knowledge to build properly with custom coding and everything that you need on, for instance, Vertex AI or other technologies. Now, there are also, let's say, the possibility to use, as I've mentioned before, DataFlow, as well as traditional notebooks and BigQuery in order to cover all the steps. And if you look at the control and all the logic, how everything is being done, you would see that Vertex, let's say, the user interface there would give you all the possibility to do the training, the notebooks, which you are very familiar with, as well as, let's say, the prediction and how to tune it so that it's being put into production as fast as possible. I was pretty much in a rush so that we cover, I think, an important topic. This will give you an insight how everything will look like, how it will be in Vertex AI, and also some features that are available right now in preview, or they will be generally available soon, or they've just been launched, so for you to see. Most of them are screenshots. It's pretty much what I can share with you at this moment. Hopefully it's interesting and will get you, let's say, some interest in to follow more. Feature store is pretty much the area where you would be sharing and using ML features. It's a central repository. You have a screenshot on the right side, how it looks and how it can all be put together. It's pretty much for reusing training, and you do not need to rebuild a lot of the features that you follow there. As well as you do a lot, everything is related to tracking and monitoring for the quality the features is being done. So a lot of the manual work that you and we all had to do related to feature engineering is covered in one place, specifically if we're working with thousands of features that need to be used in different models, and how it's all being impacted and linked to those models. So feature store is one of the preview features that will be that are available in Vertex AI. Model performance. There's a lot of, let's say, information right now, a lot of visual information that is available for the monitoring of and modeling performance. Is pretty much linked to monitored and alerts. A lot of these can be built on your own, or you can actually leverage them as fast as possible. As well as, for instance, when there are some triggers in order to automatically update the model, like for retraining pipelines and so on. And definitely diagnose is what something you'll be doing on a regular basis. Experiment tracking is something that I've missed on some of the slides before. Experiment is a big part of science in data science, because as any other, let's say, science area, experimentation is a big part of it, and this needs to be as free as possible. And this is, again, coming back to the framework of adoption important, so that data scientists involved in this kind of experiments have access to the right data whenever needed, in order to properly experiment and build the right models and so on. Again, you have here a lot of features such as tracking all runs and metrics in a central place. As you can see the scene here, you can see a lot of fields. Some of them are, let's say, must there, so it's not a matter of seeing proper figures. How you actually compare multiple experiments, what's happening, to see which one is more appropriate, or get some insights that would be useful, as well as sharing and collaborating on the experiments with other users. It's also an important feature to mention here. ML metadata. Again, getting back to an important topic that we discussed is how metadata and documentation related to how we use, how to build models, on what we build, which are the results, is also very important. And you have a screenshot there in order to see what kind of, let's say, information can be seen and how, let's say, this kind of approaches are needed. Matching engine is also something that's, let's say, quite interesting. If you'd like to find more, try to go on Google for the paper related to SCA-NN and see how it works and all the logic behind it and how it's actually being implemented. NAS, we've talked about it in a few slides before. It's pretty much privately generally available right now. One important aspect is that most of the ML, let's say, running on GPUs is fairly expensive, especially for large amounts of data and, let's say, unstructured information that we play with in some specific models. And this is trying to pretty much help in this direction, especially once you have very complex data and you don't know where to start with. What's very interesting is pretty much the integration with Vertex AI together with BigQuery ML. BigQuery ML is quite a, let's say, a new player in the Google Cloud platform in terms of machine learning features. However, a lot of models have been already implemented. There's an integration with TensorFlow, as well as a lot of more other features like AutoML models that you can play in BigQuery and so on. So the idea is to give the possibility to other analysts, or let's say more into the business analysts, the data analysts, the possibility to build their own models from, let's say, scratch or very simple ones to do, I don't know, forecasting, segmentation, a prediction of some kind, or even extinct gradient boosting and so on. So all these can be done right now in BigQuery. And if you follow the page, there will be a lot more models being put there once they are available for everyone to play with. Okay, and this gives us a few minutes, hopefully, to focus on one customer. I like Spotify, not because of the picture there that's a very well-known, let's say, road in Romania, across Carpats Mountains. That's, let's say, also one of the most traffic during the summer, which I invite you to see. However, just because they have started and they've done quite a lot of interesting things in the ML departments that they have, and they are quite open to discuss a lot of these things and how they've been playing back and forth with some technologies, their adoption, and so on. You have the link at the bottom, sorry. So you'll be able to read all the story with all the details. I'll just try to go through some of the topics and areas that I've covered in a few seconds. So in 2018, they had the platform, as you can see, generally on the left side there, with the data processing, feature engineering, training, evaluation, and model, let's say, productionizing. And what's important is that they're mentioning a lot of skills coming from both Scala and Python in terms of development, and that this was also a big issue when they tried to adopt features such as TensorFlow, because most of the knowledge and some of the models that they had were built in Scala, and most of the people in the data science world were used or had only knowledge of Python. So this was a major gap that they had in order to see how to adapt and how to cover this gap in the future. They've continued with the TensorFlow Extended, which is pretty much one of the paid versions of TensorFlow that Google Cloud Platform is offering. And they've put quite a large bet in this direction. There were quite, in 2019, when they started playing with it, there were a few new things that were being launched and they liked very much, like the data validation, the TF transform. So I'll leave it up to you to read the details. What they faced is that once they moved to Python, there were quite a lot of issues and losing some of the interest, or let's say the power development that was being done on previous models that were non-Python, as well as the adoption of TensorFlow was, let's say, a big change for them in terms of architecture. So what they did in 2020 is pretty much putting together a vindication with Kubeflow. They're talking about, let's say, also some gaps that they had to cover, and that they built their own, let's say, bridge between TensorFlow and Kubeflow, so that everything was being managed by their, let's say, needs and their expectation as good as possible. In terms of how this was done, I'll leave the details for you. Just a few lessons learned, very summarized, taken from the article there. They said that building infrastructure with our users move us faster. It was related to both of their partners and how everything was put together so that they adopted technologies as they were available. The infrastructure evolution takes a toll on our users, definitely on what was built in the past and how, let's say, they've lost some of the, let's say, interest in some directions, as well as standing on the shoulders of giants, talking about the usage of, for instance, technologies that are available in Google Cloud and how they actually become right now a giant and others are sitting on their shoulders. And this is the end of my presentation, and I thank you for your interest. And hopefully we have a few more minutes to, let's say, have some questions. Thank you.
Yes, we have. Thank you very much, Darian, for your talk. So let's start directly with the questions. Is Vertex AI replacing stuff like Google Cloud NLP platform, or is it complementary?
There are a lot of, let's say, I'll leave it up to you to see on the website. I'm just, let's say, curious to see what people will react after it. The answer is no. There are a lot of, let's say, technologies here that are overlapping, but the direct answer, sorry, is no.
The short one and longer before we go to the website. Just want to.
Sure.
Do you want?
The idea is that Vertex AI is trying to bring mostly data scientists all the development power of almost everything that Google has in terms of the AI world, so that you can put together a lot of models that were, let's say, available through specific, I don't know, coding, tuning that was pretty much hard to do, or they needed to integrate it and it was not that straightforward, and how all the model management and everything that's related to ModelOps can be done in one place. That's the whole idea related to it.
In the meantime, organizers put a link to this Spotify story at the comment, so everyone interested can read the story. And there's also another question for you, again about Vertex AI, of course. Is Vertex AI replacing stuff like Google? That was the first one. How Vertex AI is related to the Kubeflow?
So I think they complement one another. There are a lot of, let's say, interesting things that you can do by putting them together. I think there are a lot of things to discuss here. I'm not sure that I have all the details right now, and I'm trying to think what I can tell you right now in terms of availability of, let's say, Vertex AI. Most of the features there would be available as soon as they are launched. Again, this is very new also for me in terms of what I can tell you and what stories I can reveal. Most of the information would be available quite soon on the public websites and so on, and communities, GitHub, and so on.
Okay, so then we have no other choice than keep waiting for the answers. Dorian, thank you very much for your talk, and hope to see you in the networking session.
Thank you.
So that concludes our meetup for today. Thanks all three speakers that brought, I think, at least for me, very interesting talks about MLOps and about how different companies see the MLOps and what are their solution. But before we end this part, I would like to point out another virtual event that will happen in next 2 weeks. I already mentioned SAS ModelOps webinar. You have a link in the comments. So this event will be in Czech, and we will speak with. There will be a roundtable with people from different companies like O2 or Skoda Auto, and they will share their experience from practice, how to organize MLOps in an organization. And also, I would like to invite you all to the new type of talks, which is prepared jointly by MLMU and AI Center of Czech Technical University. And the first talk will happen on June 7th, and the topic will be the long history of AI. So if you're interested in the history of AI, by Nathan Ensmenger from Indiana University, join us and other machine learning enthusiasts on June 7 at 7:30 p.m. To talk the long history of AI, organized by AI Center of Czech Technical University and machine learning meetups. Thank you very much for staying with us. There are more than 100 people joined this meetup, so I hope you enjoyed the time. I hope it was worth it for you, and we will be very happy if you join also the networking session. The link again, I hope, is already in the comments. So just join the session. We are using new platform. It's quite interesting to use it. You can create the groups with other members of the community, other attendees, also with people from MLMU organization. But most importantly, you can ask questions directly to the speakers, and you can speak with them face to face or probably screen to screen. Really looking forward to see you again on the next meetup, and have a wonderful evening.